Step 28 is all about trigonometry. It's going to probably seem like a little bit of review from some of the previous math classes you may have taken, but it's a really important concept. It's something that's used frequently in the real world because of indirect measurement. It's very rare that people actually measure great distances using things like rulers and tape measures. Instead, they use indirect measurement using trigonometric ratios to figure out how tall things are, how far things are. And we're going to actually do several examples like that so that you get a good understanding of it. If we look at this first triangle here, you'll notice that this angle right here, angle B, is labeled theta. That's a Greek letter theta, and it's often used to represent the angle that we're looking at. These are all going to be right triangles, so they will all have a 90-degree angle, and then they will have two acute angles because it's impossible to have an obtuse angle in a right triangle. Then from there, we are going to label the sides. The first side that we label is opposite the 90-degree angle. It's the hypotenuse. We usually just label it with an H. The next side that we'll label is the side opposite the angle we've identified. So here we're talking about angle B, angle theta. If I go across, I get to the opposite side. I'll label it with an O. And that leaves the adjacent right here for our final side. We have our opposite, hypotenuse, and adjacent. From here, you might remember the little tip, the mnemonic device called SOHCAHTOA. It's a great way to remember these ratios for the various trig ratios, various trig functions. For instance, sine is the opposite side over the hypotenuse side. Opposite over hypotenuse, O over H. That's where these trig ratios are actually coming from. See, the S, O, H makes so, and so on. Right, in this first triangle here, again, we would label 5 as the hypotenuse. We would label 4 as the opposite because it's opposite angle theta. And we would label 3 the adjacent side. From here, we can write the major trig functions, which would be sine, cosine, and tangent, by just putting the ratio of the numbers together. We also have their reciprocal functions right next to them, right here. The easy one is tangent becomes cotangent. Notice that in tangent, it's the ratio of the opposite to the adjacent, but with cotangent, it's the adjacent to the opposite. It just flips like a reciprocal. It's a little tricky to remember. Sine goes with cosecant, and cosine goes with secant. Just remember, they have to each have an S and a C. C and an S. Let's take a look at this first example here. Again, labeling my sides. 17 is the hypotenuse. It also says it here in the given information. We know that with respect to angle theta, or angle A, this side, side BC, that has a length of 8, would be the opposite. And that leaves 15 as the adjacent. From here, we can label these different trig ratios. They're going to be ratios, so they're all going to have a fraction. And from here, we just write the ratios. So if I want the opposite, that's 8 over the hypotenuse, that's 17. To find the cosecant, I'm just going to take the reciprocal, 17 over 8. For the cosine, now I need the adjacent, 15. The secant, the 15 will be on the bottom. And again, the hypotenuse is always 17. For the tangent, I want TOA, T-O-A. I need the ratio of the opposite, which is 15. Nope, I wrote that wrong. The opposite is 8. The adjacent is 15. The opposite is 8. And then taking the reciprocal of 8/15, we'd have 15 over 8. Now, the next problem asks you to find the values of the six trig functions for angle B. If I'm looking at angle B instead of angle A, now this is the acute angle that I'm referencing. If I go across the triangle, this side is now the opposite, leaving the side with length 8 to be the adjacent. So it really depends on where the angle is. That's going to change things. For instance, now, if I take the sine of angle B, up here when we did the sine of angle A or the sine of theta, it was 8/17. Now it's going to be 15/17. It's going to change. All these ratios will change because we have a different reference angle. On this next problem, it tells us that the sine of angle B, so this is our angle that we care about, angle B, is 5/8. Remember, SOHCAHTOA if they're telling us about the sine, that means 5 is going to be the opposite. And 8 is going to be the hypotenuse. Because we need the opposite over the hypotenuse. But we don't know our adjacent side yet. We know it's over here, that's the adjacent side. To find it, because it's a right triangle, we just use the Pythagorean theorem. We say that a squared plus b squared equals c squared. A squared plus 5 squared equals 8 squared. Simplifying and solving, we then see that a is radical 39 because it can't be negative. So I'm going to label that on my triangle, radical 39. And now we can find all the ratios. The first one is pretty simple because we know it's going to be the reciprocal. So now we just put 8/5 for the cosecant. But the other ones are going to involve the adjacent side, so we really needed to figure that out. For the cosine, that's going to be the adjacent, which is radical 39, over the hypotenuse of 8. The tangent, actually before we do that, let's go ahead and flip it for the secant. That would be 8 over radical 39, but that's a problem. We can't have a radical in the denominator, so we multiply by radical 39 over radical 39, and our final answer is 8 radical 39 over 39. The tangent is going to be the opposite over the adjacent, TOA, 5 over radical 39. We need to rationalize that again by multiplying by radical 39 over radical 39. We get 5 radical 39 over 39. For the cotangent, I need to flip this, but I don't want to flip it in this state. I actually want to go back to what I started with. So I end up with radical 39 over 5. It's much simpler. It's a little bit of a shortcut. We're also going to have some special angles right here about the special right triangles. You may recall from geometry studying the special right triangles where they had special ratios for 30, 60, 90 and 45, 45, 90. How you could multiply the short side by 2 to get the hypotenuse and the short side by radical 3 to get the leg. When we look at this with respect to one of the angles, for instance, 30 degrees, if we want to find the sine of 30 degrees, the hypotenuse is 2x, the side opposite is x, so I need to take my opposite over my hypotenuse, and then I will simplify, leaving me with 1/2, which is exactly what we get over here. You don't have to have these memorized, it's just kind of nice to see some of the common special angles and how you get those ratios, why they equal what they equal. On example 3, we're going to find the missing side. We know that the hypotenuse is opposite the 90. We know that the side opposite the angle that's labeled, that's the only angle we care about, would be right here. And finally, this would be our adjacent side. With the hypotenuse, I know it's 8. With the adjacent, I know it's the side I'm trying to find. The opposite, though, I know nothing about it. I don't want to know anything about it, so we just cross it out. Or you could erase it. Next, I'm trying to figure out what trig ratio relates H and A. If you need, write it out. So katoa. H and A is best to use cosine. So we'll say that the cosine of 30 degrees is the adjacent over the hypotenuse. And then we'll solve by multiplying by 8 on both sides. Now, we can look at our special angles and know that the cosine of 30 is radical 3 over 2. But instead, we can also just use our graphing calculator and type 8 times the cosine of 30. But before we hit enter, it's always good to check by pressing mode to make sure that your calculator is in degree mode. If it's in radian mode, you'll get the wrong answer. That's a different way to measure. It has to be in degree mode. Make sure degree is highlighted and hit enter. And then quit and get back to our problem. And we get 6.928. It says to the nearest tenth. So we would say x is approximately 6.9 for our answer. Let's do a real world problem so you can kind of get an idea of why we're using indirect measurement. Here we have Joel standing 200 feet away from a very tall building. We know that from his eye level to the ground, it's 6 feet. So from about here to here on the building is 6 feet. That means Joel is probably about 6'3", 6'4", something like that. But from his eyes to the ground, it's about 6 feet. Next, we're trying to find D, side D. So let's label things. We know that this is our hypotenuse. We know that the side opposite 76 is right here. And that leaves this side down here that's 200 feet. That's our adjacent. Again, looking at this triangle, we want to know what the opposite side is. That's the D height of the building. We know what A is. It's 200 feet. That's how far Joel is away from the building. But we don't care about the hypotenuse, so you could erase it. Now we're trying to find a trig ratio that connects O and A. That would be tangent. Tangent of the angle, 76, is the side opposite that angle over the side adjacent to that angle. And again, solving by multiplying by 200 on both sides. Now we can see, using the calculator, 200 times tangent of 76 is 802.156. But again, that's the height of the building from here to here. We'll just call it 802 to keep it simple. We need to know how tall the building is. Since the tool that he used to measure this angle was 6 feet above the ground, because that's how high his eyes are from the ground, we need to add 6 feet to this to get approximately 808 feet.